Data modeling is one of the features of Power BI that is used to connect multiple data sources in the BI tool using a relationship. A relationship defines how data sources are connected and can create interactive data visualizations on multiple data sources. With this feature, you can build your own custom calculations on the existing tables, and these columns can be directly presented into Power BI visualizations. This allows businesses to define new metrics and perform custom calculations for those metrics. Let's see some objectives. We will create relationships between your data sources. We'll create new field with the calculated columns. We'll optimize the data by hiding fields and sorting visualizations data. We'll create a measure to perform calculations on your data. Use a calculated table to create a relationship between two tables and format time-based data so that you can drill down for more details. Hello, my name is Amin Khan and I am a Power BI developer, a project manager, and a YouTube instructor. I will guide you through the rest of the process of data modeling in Power BI. But first, if you are new to my channel, please subscribe it and hit the bell icon so you can never miss any video by Code Gems. We'll start with the strength of Power BI. One of Power BI's strengths is that you don't need to flatten your data into a single table. Instead, you can use multiple tables from multiple sources and define the relationship between them. Also, you'll create your own custom calculations and assign new metrics to view specific segments of your data. Let's see our practical approach. To follow along with our practical approach, download the sample access data file from the link given in the description below and import it into the Power BI desktop. And if you have any issues loading the Access database, please read the following link. I will provide the link in the description as well. From this link, you will have the better idea to how to load the Access database in Power BI desktop. Let's import the data first. I will go to Get Data and way down to the More option. I will go to the database and from there I will select Access database and will hit connect. This file is ready to import into the Power BI desktop. I will open it. Here you go. We have the tables available. I will select all of them and click load button. So you can see over here the data has been loaded into the field pane. We have three views available for our data sets. Number one is report view. Number second is the data view. You can see over here we have the available data in the data view with the columns. We have date and sales and products and manufacturers. So this is the beauty of Power BI, that we do not have to flatten the data in only one table. We can have multiple tables from the multiple resources, and you can see over here we have millions of rows of data available in the Power BI desktop, and this engine is so much powerful. You can access the data and you can go around the final row of this data very quickly. The model view in Power BI desktop allows you to visually set the relationship between the tables or elements. A relationship is where two or more tables are linked together because they contain related data. This enables users to run queries for related data across multiple tables. You will use the model view to see a diagrammatic view of your data. Let's move towards the model view of the data. In the model view, notice that each block represents each table and the lines between them represents a relationship. Adding and removing relationships is straightforward. To create a relationship, drag the field from here to another table. I will create a relationship between the sales and the date table. So I will take over here and drag this one up so you can have the better understanding. So to create the relationship, I will drag this date field to the sales. So you can see over here the relationship has been created, and if I want to remove it, I just simply click over here the relationship and delete it. Hit the delete. So here you can see I'm able to delete the relationship. To hide a table or individual column from your report, just right click the table or column in the model view and select hide in report view. So the table in our visualization or analysis will not appear at all. And if you want to hide the individual column, just have the right click and hide in the report view. So you can see over here this column has been hide. If you want to use this eye option, so from here you can also hide and unhide the column or table in the model view. For a more detailed view of your data relationships, select Manage Relationships. The Manage Relationships dialog box displays your relationship as a list instead of as a visual diagram. So you can see over here, this is the beauty of Power BI, that it automatically detects the relationship that is already been created. So we have a relationship with the product table, with manufacturer, sentiment to the manufacturer, and the sentiment product ID to the product. From the dialog box, you can also auto detect to find relationships in new or updated data. So if you have a new or updated data, so from the auto detect, you will have the updated view of your relationships. From here, from select edit, you can select edit to manually edit your relationships here. And from here, you will find advanced options in the sections to set the cardinality and cross-filter direction of your relationships. Let's discuss the concept of cardinality of the relationship. When you create a relationship between two tables, you get two values. One, which can be one or many, on the two ends of a relationship between two tables. So it is called a cardinality of the relationship. Your options for cardinality are explained in the following slides, like many to one, the most common default relationship. The column in one table can have more than one instance of a value. The related table or lookup table has only one instance of a value. And number second is one to one. The column in one table has only one instance of a particular value, and the other related table has only one instance of a particular value. Generally, we recommend minimizing the use of bidirectional relationships. They can negatively impact model query performance and possibly deliver confusing experiences for your report users. Setting accurate relationships between your data allows you to create complex calculations across multiple data elements. Let's learn the cross-filter direction. Typically, it expects the relationship in both directions. When filtering the tables to create appropriate view of data, report creators and data modelers face challenges determining how to apply filters to a report. Previously, the table's filter context was held on one side of the relationship but not the other. This arrangement often required complex DAX formula to get the wanted results. With the bidirectional cross-filtering, report creators and data modelers now have more control over how they can apply filters when working with related tables. Bidirectional cross-filtering enables them to apply filters on both sides of a table relationship. You can apply the filters by propagating the filter's context to a second related table on the other side of a table relationship. Sometimes the data that you are analyzing doesn't contain a field that you need. The answer might be a calculated columns. You can create a new calculated column by transforming two or more elements of existing data. For example, you can create a new column by combining two columns into one. One reason for creating a calculated column is to establish a relationship between tables when no unique fields exist. The lack of a relationship becomes obvious when you create a simple table visual in Power BI Desktop and get the same visuals for all entries. Let's have a quick look at how we can create a calculated column to enhance our data set. I'm working with the sales data here. You can import this updated file from the link in the description below with an updated geography table in it. We need to create a relationship between sales and geography table, but before, let's see, there is no relationship between the tables, so what will happen with the results when combining the tables? I will drag the district from geography table and from the sales table I will drag the revenue. If I make it a bit large for you people, so you can see over here that there is a same revenue for all districts just because there is no relationship between these two tables. To establish a relationship, we'll go in the model view from here. Here I cannot only drag and create a relationship as we do not have any unique key here that defines a relationship. Like if we check over here with these tables, manufacturer and the sentiment table column, so you can see over here we have the manufacturer ID in this column, and in this table you can see over here we have a manufacturer ID as well. So because of this unique key identifier, we have the relationship created in such a way that we have one-to-many relationship between these two tables. And if we go and check this product table, so you can see over here we have the manufacturer ID, and here in the product table you can see over here we have the manufacturer ID as well. So the cardinality has been set to one-to-many over here. Here if we look at the zip column, so zip column cannot be a unique key because zip can appear in two different countries. So here what I'll do, I'll combine the country and zip column to create a unique key in both tables. And to do that, let's go to the data view. We'll select the geography table from here, and from the bunch of the options here in the ribbon, I will select a new column. So you can see over here, it's giving me a new column and introduces a formula bar to create a formula. To create that formula, the language that I'll use is DAX, the data analysis expression. DAX is a programming language used in Microsoft Power BI for creating calculated columns, measures, and custom tables. DAX is a collection of functions, operators, and constants that can be used in formula or expression to calculate and return one or more values. Here I want to combine the country and zip columns. So first of all, I will give the name to the column, country zip. I will write country. Let's stop here and see. Look, when I start typing there are various functions and options become available. So this is the beauty of Power BI and DAX formulas, that the available formulas and options will be introduced when we try to type any of the functions over there. So I will write country and select the geography from here, and I will provide the ampersand and the comma and again the ampersand. Now I will write the zip, so we have geography zip, and I will hit enter. So you can see over here we have successfully concatenated the tables easily. Now we will do the same for the sales tables as well. So I will click the sales table and go to the new column. I will write country zip. I will write country have sales country, ampersand, comma in between, and the zip. Okay, then hit enter. So it's also done for the sales table. I'll go back over here and create a relationship between these tables. So I've just dragged this country zip to this table. So you can see over here that relationship has been created, and cardinality as well. This is many to one. So I will go to my report view, and here you can see the correct revenue has been generated against the individual districts. Imported data often contains a field that you don't need for your reporting and visualization tasks. Data might contain unnecessary information, or it might be available in another column. Power BI Desktop has tools to optimize your data and make it more usable for building reports and visuals. To hide a field in the fields pane of Power BI Desktop, just right-click the column and select Hide. Your hidden fields aren't deleted. If you have used a hidden field in existing visuals, the data is still there. The hidden field just isn't displayed on the fields pane. If you view the tables in the model view, hidden fields will be marked as hidden in the I options over here. The data in these tables is still available and is still the part of the model. You can unhide in any field that has been hidden by right-clicking the field and then selecting the unhide. Click over here and then go to hide in report view and click this one. So here you go. We have successfully unhide this geography table. The Sort by Column tool available on the Table Tools tabs is used to help ensure that your data is displayed in the order that you intended. As a common example, data that includes the name of the month is sorted alphabetically by the default. For example, August would appear before February. In this case, selecting the month name field in the field list, selecting Sort by Column from the tool tables, and then choosing a field to sort by can remedy the problem. The month's number category sort option will order the month as intended. Setting the data type of a field is another way to optimize your information so that it's handled correctly. To change data type from the report canvas, select the column in the fields pane and then use the Format drop-down menu on the Columns Tool tab to select one of the formatting options. Any visuals you have created that display that field are updated automatically. In Power BI, measures are defined calculations on your data that are performed at the time of your query. Measures are calculated as you interact with your reports and aren't stored in your database. To create measures, we use DAX, and DAX is a very powerful language that helps us to do some big calculations with predefined functions and expressions. Specifically, it is very useful when it comes to time-based calculation. And it is a very powerful in such a way that you will define things once and you can use them anywhere in the table. Let's look at an example. Jen is a sales manager at Contoso. Jen has been asked to provide reseller sales projections over the next fiscal year. Jen decides to base the estimates on last year's sales amount and with a 6% annual increase resulting from various promotions that are scheduled over the next 6 months. To report the estimates, Jen imports last year's sales data into Power BI Desktop. Jen then drags last year's sales onto the report canvas. It appears in a chart visualization as single value, that is sum of all the reseller series from the last year. Jen needs a measure to calculate sales projections for the coming year, which will be based on last year's sales multiplied by 1.06 to account for the expected 6% increase in the business. For this calculation, then we'll create a measure using the new measure feature. To create a measure in report view, select new measure from the modeling tab. We'll go to modeling and from the new measure. From the formula bar, you can enter the DEX expression that defines your measure. As you enter the calculation, Power BI suggests relevant DEX functions and data fields. You will also receive a tooltip that explains some of the syntax and function parameters. And if your calculation is long, you can add extra line breaks in the expressions by typing Alt-Enter. Let's see our practical approach on it. We'll create a projected sales column, projected sales, and as per the scenario we have, we will use a sum function over here. You can see we have different functions over here with the help of the tooltips what these functions does. So we will use a sum function and we'll call a column over here which is reseller sales, this one, and it will be multiplied by 1.06 as per the 6% increase in the expected revenue. So we will hit enter. Before hitting enter, I would like to tell you about the expression that if it is long, so you can have alter enter and it can be available in the second line, so you can most probably have a good indentation of your code over here. Enter. So you can see over here we have the projected sales column has been integrated and this is our measure. After you created a new measure, it will appear in one of the tables on the fields pane, which is found on the right side of the screen. Power BI inserts the new measure into whichever table you have currently selected. While it doesn't matter exactly where the measure is located in your data, you can easily move it by selecting the measure. I will select this measure and then go towards the home table and select the tables. Wherever I want to send this column, I will send this measure, in fact I will send it to the different table. Like if I hit the date, so you can see over here there is no projected sales column over here and it has been shifted towards the into the date table. I will hit back and hit to the reseller sales table as well. Now you can use a measure like any other table column. Just drag and drop it into the report canvas or visualization fields. Measures also integrate seamlessly with slicers, segmenting your data on the fly, which means that you can define a measure once and then use it in many different visualization. Like I will select the stack column chart and instead of it I will select the clustered column chart over here and I will drag to make it a maximize a bit. I will send the year and the original sales that we have and the projected sales. If I make it a bit large for you, so you can see over here we have this one, we have sales for $4,000 and projected sales is $4,240. We can also have data colors, or we can go to the view and change the theme of our charts as well. Now we will see some calculated tables. Calculated tables is a function within DEX. Most of the time you can input the data in your model from an external data source. However, calculated tables provide intermediate calculations in data that you want stored as a part of the model rather than as a part of a query. You can use calculated tables, for example, to cross-join two tables. To create a calculated table, go to the data view in the Power BI desktop. Now go to the new table. So you have the new table available here. Type the new name of the table. I will use the Name of the table will be country, and I will be using the distinct functions from DAX. And what is the distinct function? We will go and check in our Power BI documentation. Distinct table returns a table by removing duplicate rows from another table or expression, and this is the syntax, and these are the parameters. I will provide you the link of this documentation in the description below, so you can have you can have a look what is the syntax and what is the definition of this function. In our practical approach, we will have the unique fields of the country, so I will use the distinct function, and here I will use country column and bracket close and hit enter. Here you go, you have the distinct and unique name of the countries. So all of the redundant data by the countries has been removed, and we have unique rows. After the new table has been created, you can use your calculated tables as you would any other table in relationships, formulas, and reports. Analyzing time-based data with the Power BI is a simple process. The modeling tools in Power BI desktop automatically generate fields that let you drill down through time periods. When you create a table visualization in your report by using a date field, Power BI desktop automatically includes breakdowns by time period. For example, the single date field in the date table was automatically separated into year, quarter, month, and day by Power BI. Let's have a quick look to the time-based data. I will go to the report view, hit back. I will use the table 1 over here. I will use the clustered column chart, and here in the values I will put the sales, and to create a drill through I will put all of my options in the axes. I will make it a bit large for you so you can view it easily. So we have states, and in the states we have regions, and in the regions we have multiple managers, and in manager we have a salesperson working under managers. We have categories of the products, we have subcategories, and in the end we would like to see the data by month. So here you can see right now we have the state over here, so the data in the clustered chart is represented according to the states. Now I will go towards the data drill over here and click drill down. So you can see here we have the drill is on over here now. So if I want to go to Hawaii, so you can see we have South region, and if I click on it we have the manager, and after that we have the salesperson. After we have a category, we have subcategory, and in the end we have month, and in the month we can say that we have around $4,000 sales has been acquired. And secondly, we have drill up. If you want to see the previous data, so you can click drill up and see the data is changing right now. You can also drill down through all the data that is shown on the visual instead of through one selected period. To do so, you go to the next level in the hierarchy with the double row. If I click over here, you can see we have different states with the different regions, and after that we have the managers, after that we have the salesperson, and after that we have a category, subcategory, and months. So this is the another way to view your data. I will go back from here and I can select any of the states, and here I can see the state wise data with the help of the drill. So what you have learned so far: introduction to the modeling data, how to manage the data relationships, how to create the calculated columns, how you can optimize the data models, how you can create the measures, how you can create the calculated tables, explore the time-based data through drill, and last but not the least, we have a quiz to check your knowledge. Please click on this link and test your knowledge. We have a couple of questions regarding your data modeling chapters. And congratulations! In this module, you have learned how to create relationships between your data sources and optimize data. These skills will help you pull clean data from several different sources.